Now chapter number 12, atoms. So during the development of the study of matter, scientists established this thing. The matter is made by the smallest particle named as atom, and size of atom was also decided in those days, that is of the order of 10 raised to minus 10 meter. But then after, scientists carried out detailed studies related to the atomic structure also. It implies that atom is made by what? Or we can say, can atom be divided into further small parts, or is there the constituent particles in atom also? So then after, scientist Sir J.J. Thomson in his experiments represented this thing. The experiment was related to the electric discharge in the rarefied gases. So he proved this thing. The negatively charged particles, he named those negatively charged particles as electrons, are present in atom. Okay. So he proved this particular thing. But it was already established atom is electrically neutral. So when atom is electrically neutral and negatively charged particles are there inside the atom, which are known as electrons. So definitely there should be the same amount of positive charge inside the atom. Then and then only, if we take the algebraic summation of all the charges residing in the atom, we will get the net charge, that is 0, and then only the atom will be electrically neutral, otherwise not. Okay, so this thing was established. Inside the atom there are positive charges, means positively charged particles, as well as negatively charged particles. But then after, the question arises how these positively and negatively charged particles, or we can say positive and negative charges, are arranged in the atom. Okay, એટલે કે એટમિક સ્ટ્રક્ચર હવે આખું સ્ટડી કરવાની વાત આવી, રાઈટ? So very first, scientist Sir J.J. Thomson represented the atomic model, which one was known as plum pudding model or watermelon model. He suggested this thing: the entire positive charge is uniformly distributed in the atom, just like a pulp distributed uniformly in the watermelon, and like seeds in the watermelon, the electrons are embedded in that positive charge. But in those days, the other experiments related to the atomic spectras, એટલે કે બલ્ક મેટર જે હોય, સોલિડ લિક્વિડ અથવા તો એકદમ ડેન્સ ગેસીસ, રાઈટ? તો એ હાયર ટેમ્પરેચર ઉપર આપણને સર્ટેન રેડિયેશન્સ એમિટ કરી આપે. તો એ જે સેટ ઓફ wavelengths of radiations મળે છે આપણને, that is called spectra of that particular element. તો એવા કન્ટિન્યુઅસ સ્પેક્ટ્રા બી મળે આપણને બલ્ક મેટર માટે, કન્ડેન્સ મેટર માટે. And if we take the rarefied gases, means if the gas is filled in the tube at very low pressure, and then after if we find out the atomic spectra of it, then we get line spectra. So all these studies related to the atomic spectra were not explained with the help of this plum pudding model. So in short, we can say that particular model was totally failed. Okay, but then after, scientist Rutherford, who was a student of Thomson, was studying about the alpha particles emitted from the radioactive substances, or we can say radioactive elements. Then he suggested this thing: if we perform the classical experiment in which we carry out the study related to the scattering of alpha particle from the atom, then we can study about the atomic structure. Thereafter, two students of Rutherford, Geiger and Marsden, specifically performed the experiment related to the alpha scattering, which one was suggested by Rutherford. અને રુધરફોર્ડની દેખરેખમાં અને એની અંડરમાં Geiger and Marsden performed this experiment. Clear to all of you? Now here the schematic diagram of the experimental arrangement is represented in this particular figure. Okay. Here this one is the source of alpha particle. Actually that particular source of alpha particle, that is Bi83. Okay, that particular element emit the alpha particle. Okay, these alpha particles are with energy equal to 5.5 MeV, and by passing through this particular alpha particles emitted from the Bi83 through the lead blocks or bricks, we can say, the beam of emitted alpha particle was collimated and then incidented on the thin gold foil. This particular gold foil was very thin, that was of the order of thickness 2.1 into 10 raised to minus 7 meter. Then there was a rotating detector, that is the thing but the microscope, with zinc sulfide screen. That particular screen is scintillating screen. It implies that when any charged particle incident on that particular screen, then momentarily it give you the glow of light. એટલે લાઇટ નો જે આપણે નહીં કહેતા કે ચમકારો થાય, એવો કોઈ નેગેટિવલી કે પોઝિટિવલી ચાર્જ પાર્ટિકલ એની ઉપર ઇન્સિડેન્ટ થાય એટલે તરત જ ત્યાં તમને લાઇટનો ચમકારો આપે, રાઈટ? સો by seeing through this microscope, you can calculate the scintillation formed on the screen, and one can calculate the number of alpha particles scattered from the gold foil at a particular angle of scattering in the given time interval. Okay, see, this one is the direction of motion of alpha particle when it incident on the gold foil, and if after incidenting on the gold foil it move in this direction, then the angle between the original direction of the propagation and the direction of propagation after scattering, that is called angle of scattering. That is called angle of scattering. So here they calculated the number of alpha particles scattered at a different angle of scattering. And then after, they plotted the graph of number of alpha particles scattered at a different angle of scattering. એટલે આ જે અહીંયા ગ્રાફ બતાવ્યો છે, આવી રીતના ડોટ્સ એમને મળ્યા. And in this particular experiment, they observed this thing. Majority alpha particles propagate at very small angle of scattering, that is less than 1 degree. Hardly 0.14% number of alpha particles scattered at the angle greater than 1 degree, right? And hardly one alpha particle out of 8,000 scatter at angle of scattering greater than 90 degree. એટલે જો અહીંથી alpha particle આમ પડ્યો, બરોબર છે, અને આ જે ગોલ્ડ ફોઇલ છે એને નોર્મલ અહીંયા ઇન્સિડન્ટ થયો, એટલે આ જે એંગલ છે એ 90 ડિગ્રી થયો એનો, આ ડાયરેક્શન ઓફ પ્રોપેગેશન અને ગોલ્ડ ફોઇલ. હવે જો અહીંયા ઇન્સિડન્ટ થઈ અને આ રિજિયનમાં ક્યાંય સ્કેટર થાય, અહીંથી અથડાઈને આ બાજુએ ક્યાંય આવે, અથવા તો અહીંથી અથડાઈને આ બાજુએ ક્યાંય જાય, આ પોર્શનની અંદર, રાઈટ? તો એંગલ ઓફ સ્કેટરિંગ ધેટ ઇઝ ગ્રેટર ધેન 90 ડિગ્રી કહેવાય, રાઈટ? So these type of observations were taken. Clear to all of you? Here the gold foil was taken very thin, that is with thickness 2.1 into 10 raised to minus 7 meter. So very first thing that one can conclude like this, and Rutherford also concluded that thing, when alpha particle incident on the gold foil, then it suffers only one collision. એમાં મલ્ટિપલ કોલિઝન્સ થતા નથી, કારણ કે બહુ બધા જો લેયર્સ હોય તો મલ્ટિપલ કોલિઝન્સના ચાન્સીસ આવે, પણ આટલી બધી થીન ગોલ્ડ ફોઇલ હોય એટલે મલ્ટિપલ કોલિઝન્સનો ચાન્સ આવતો નથી એની અંદર. સેકન્ડ થિંગ, the atom of gold that is approximately 50 times heavier than alpha particle. Alpha particle, that is nothing but helium nuclei, right? So during the collision we can consider that gold atom that remains stationary. Okay, now alpha particle that possess 2e unit positive charge, and when head-on collision takes place, it implies that when the collision of the alpha particle takes place with the atom and when it rebounds, it scatters approximately very close to 180 degree, then definitely it experiences strong repulsive force. And when helium possesses 2e unit positive charge and it experiences the large repulsive force, it implies that, and it is not able to penetrate during this head-on collision to the atom, means almost entire mass of the atom is concentrated in the small tiny region at the center of the atom, and he represented this thing, that particular small tiny region in which the entire mass, almost entire mass, 99.99% mass of the atom is concentrated in that particular small tiny region, that is known as nucleus, and entire positive charge is also concentrated in that particular small region. Okay, so all these things he concluded from this one, and by considering this thing, theoretically he calculated the trajectory of alpha particles. So here trajectory of alpha particle that depends on the impact parameter of the collision. Now impact parameter means what? See here, this particular figure, this is the atom. Okay, now impact parameter of the alpha particle for collision, that is nothing but the perpendicular distance of the initial velocity of alpha particle with respect to the center of the atom. मतलब કે માનો કે alpha particle આ ડાયરેક્શનમાં મૂવ થઈ રહ્યો છે તો સેન્ટરમાંથી પાસ થતી આપણે લાઈન આ રીતે ઇમેજિન કરી શકીએ તો આ બે વચ્ચેનું perpendicular distance, that is impact parameter. હવે see, if impact parameter is small, it implies that alpha particle is passing very close to this center of the atom. So if it is passing close to it, then it will experience more repulsive force, so scattering will be at more angle. And if impact parameter is more, means large one, it implies that the distance of the alpha particle that is more, then repulsive force will be less, so it will suffer the scattering at less angle. Okay, and see here, actually in text it is not given to you, but Rutherford derived the equation for the number of alpha particles scattered at different angles, and he used Newton's law of motion, F equal to m, a second law of motion, and Coulomb's law. So as per Coulomb's law, the force between that particular center of the atom and alpha particle, that is 1 upon 4 pi epsilon 0 q1 q2, charge possessed by helium, that is 2e, that is alpha particle, and charge possessed by gold atom. So atomic number is Z. So charge possessed by it, that is Ze, upon r square, r that is the perpendicular distance, means this impact parameter. Clear? So using these equations, he theoretically derived the equation. Now this equation is just for information. ખાલી એને તમારે યાદ રાખવાનું નથી કે કંઈ વિચારવાનું નથી એને રિલેટેડ. See, equation આવું છે કે n equal to n0 small n into s into ze square upon mv square into 1 upon sin raised to 4 theta by 2. So here in this particular equation, n0, that is number of alpha particles incident, n capital N, that is the number of alpha particles scattered at angle theta, n that is number of atoms per unit volume, then s that is the thickness of the foil. So using all these parameters, he derived this particular equation. And using this equation, he calculated theoretically the number of alpha particles scattered at different angle of scattering. And then after Rutherford plotted the graph of number of alpha particles versus scattering angle, right? And that graph was a smooth curve one. And then after, very important thing, that particular graph plotted by Rutherford for number of alpha particles versus scattering angle theta, and the graph prepared by the experimental observations of Geiger-Marsden experiment for number of alpha particles versus scattering angle theta, when superposed, then they observe this thing, it perfectly superposed to each other. Clear to all of you? So now see here in this particular graph represented in the figure, this particular line represent Rutherford's observations, means calculated one, theoretical one, and these particular dots represented here on that particular curve are the experimental observations. So perfectly matched theoretical and experimental observations. It implies that Rutherford's assumption, like entire mass and the positive charge is concentrated in the small tiny region, and that is called nucleus. And here the scattering angle that depends on this impact parameter. And with the help of the head-on collision એટલે જુઓ અહીંયા ફિગરમાં અહીંથી આલ્ફા પાર્ટિકલ આમ ગયું 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 એટમની અંદર ગયું અને પછી અહીંથી રિબાઉન્ડ થયું. So they observe this thing, alpha particle is not able to reach at the center of this particular atom. એટલે કે એને 100% penetrate નથી કરી શકતું. It rebounds within the range of 10 raised to minus 14 to minus 15 meter from the center of the atom. It implies that that particular small tiny region which we say that is the nucleus, in which entire positive charge and almost entire mass of the atom is concentrated, that is with radius of the order of 10 raised to minus 14 to minus 15 meter. Rutherforde nucleus ni size પણ પછી decide કરી આપી. Clear to all of you? So here now we can understand this thing. The atom is, or we can say the size of atom, that is 10,000 to 1 lakh time more than that of the size of nucleus. Clear? And here one can now easily understand this thing when maximum number of alpha particles scatter at the angle less than 1 degree, it implies that the maximum space in the atom, that is the empty space, right? એટલે કે એટમ ન્યુક્લિયસ કરતા ભલે 1 લાખ ગણો મોટો છે, પણ એ જે સ્પેસ ઓક્યુપાય કરે છે એટમ, એની ઓલમોસ્ટ બધી જ સ્પેસ એમ્પ્ટી સ્પેસ છે, રાઈટ? તો આ રીતે એટમનું સ્ટ્રક્ચર ખ્યાલ આવ્યો. Then Rutherford suggested this thing. Yes, now in atom, entire positive charge is concentrated in the nucleus, and electrons revolves around it in different orbits, just like our planetary system. Different planets revolve around the sun in different orbits. Like that, electron revolve around the nucleus. He suggested this thing. But again, see, up to this one, he was correct one. But now the problem is this: if we consider the revolution of electrons in different orbits, now any revolving particle is executing accelerated motion. Now, if any charged particle execute accelerated motion, then it emits the energy in the form of radiations. And if it emits the energy, then energy possessed by electron will be continuously decreasing one. And if energy is continuously decreasing one, then it will not continue the motion in a particular orbit. The radius of the orbit, that will be also continuously decreasing one. So after some time, that electron will sit in the nucleus. Then what about the stability? ઓકે, એટલે આ જગ્યાએ રુધરફોર્ડ્સનું એટોમિક મોડેલ ફેલ થતું હતું. એટલે રુધરફોર્ડ્સ એટોમિક મોડેલ છે that is called nuclear model of atom or planetary model of atom એવું પણ કહેવાય છે એને, રાઈટ. એટલે મેક્સિમમ વસ્તુ સમજાવી શકાય એનાથી, બરોબર છે. બસ પછી આ ઇલેક્ટ્રોન્સ એની આજુબાજુ કેવી રીતે રિવોલ્વ કરે છે, રાઈટ, એનું અન્ડરસ્ટેન્ડિંગ પ્રોપરલી આવતું નહોતું. ક્લિયર ટુ ઓલ ઓફ યુ?